So in that previous video, we went through a lot of math, and in the course of our derivation, we developed a term in which we call the specific enthalpy. At this point, I want to take a step back and describe and discuss the physical picture that's described by the math, and in particular, I want to talk about what enthalpy physically means. Okay? And so from the math, we see that our enthalpy equation is the sum of internal energy and also this PV work, right? And I just want to mention that this is true for both open and closed systems. Even though we derived the enthalpy term for an open system, based on its definition alone, this is something that you could also calculate for a closed system if you wanted to. All right? And so we see that enthalpy is just the sum of the internal energy and PV work. Okay? But what I want to do in this video is I want to dig a little deeper to try and get a more visual idea about what this means. Let's focus on the first term here. All right? Now, for internal energy, I always say it encompasses molecular motions, atomic motions, and even subatomic motions. If we had a cloud of gas molecules, the internal energy would be describing the motion and interactions of these gas molecules. But in any case, this is still kind of an abstract idea. So to give you a more concrete picture of what internal energy is, what I want you to do is I want you to think of sheep. Specifically, I want you to think of a flock of sheep. Now, whenever sheep are grazing in a field, they like to do it in large groups or flocks. The behavior of these flocks are the same as the behavior of a cloud of gas molecules. You have some young sheep that have a lot of energy, and they're running around and zipping around all over the place. You have some older sheep that don't move so fast anymore, and they're kind of slow, and maybe they just lie down in the grass. You have some sheep who hate each other, and they repel each other. They don't want to be anywhere near each other. But you also have some sheep that are in love. They attract each other, and they want to be close. They want to be near each other. Now, all these interactions and all these motions that sheep do are the same thing that gas molecules do. And the sum of these things is described by the internal energy term. All right? So I'll write here internal energy. All right? Now, the second term in our enthalpy equation was the PV flow work. What was that? Sticking with the sheep metaphor, one way to think about flow work is to think about sheepdogs. Okay? Sheepdogs, like the one that you see here, they control and induce the motion of entire flocks of sheep. And so what the sheepdog is doing is it's really acting as pressure. And it's pressuring the volume element of sheep to go from one place to another. Okay? So the sheepdog is pressure. All right? And so to give you a visual idea of what flow work is, I want to share with you a video. Okay? And so in this video, you'll notice that in this video, what we have is a sheepdog trying to move a flock of sheep from a big field into a smaller pen. Okay? So the sheepdog is kind of in the left there. It's basically 1 pixel big. But the things in the middle, the big white groups, those are flocks of sheep. Okay? All right, and so as this video progresses, you'll notice that it's not easy for the dog to get the sheep to move into the pen. All right? It's making progress, and then it takes a step back. All right? And so you'll see that it takes a lot of effort for the sheepdog to do this. It takes a lot of work to get these sheep to move to the pen. All right? Now these sheep are moving from a big field to a smaller pen. And this action is similar to mechanical work, right? In which we're changing the size of our system boundaries, right? And so if we take the sheep to be the system, right? We see that they're going from a large field into a smaller pen. So our mechanical work on the sheep system has to be positive, right? Because we're going from a big system to a smaller one. All right? And so that was one example, or that was just a video of a sheepdog moving a flock of sheep from a big pen into a smaller one. Now let's imagine another scenario. All right? Let's imagine that we have a straight road. Right? And we have a flock of sheep on one end. So I'll just put the sheep like this. All right? And we have a sheepdog. I don't know how to draw a dog head. I guess that's good enough. We have a sheepdog trying to move the sheep from one end to the other. All right? Think of all the work that dog has to do in order to get the sheep to move from one end of the road to the other. That is flow work. All right? And so when we discuss enthalpy, we just remember that it's a sum of two terms. It's a sum of internal energy, which describes the motions and interactions within the system. And the second term is the PV flow work, right? Which is the work that's needed to move the system and also control its size.